And number 5 is saying the equation of a curve is y equals 4 cos 2x plus 3 for x being less than or equal to 0, also being less than or equal to 2 pi. Right? So x is taking values from 0 to 2 pi. Then part A says state the greatest and least possible values of y. So if we look at this, we can see that the way transformations that were applied to y equals cos x, right? And we know for cos x, for y equals cos x, we have pi and 2 pi. Then it goes from 1 to minus 1, and it's like this, right? Point here, and a point here, like that. Let me redraw that. So we have a point here, a point here, and a point here. So it will be like this, right? And for the greatest and least possible values of y, we're only dealing with the y-axis. So we're going to consider transformations that affect the y-axis. And by looking at this, we will be considering this 4, which is a stretch in the y direction by a factor of 4, and this vertical translation 3 units up, right? So we're saying if we started off with 1 and minus 1, and there was a vertical stretch of factor 4, it's like multiplying these by 4. So it's by 4 by 4. We're now at 4 and minus 4. Right? That's our new range after the stretch. Then if we add 3 units going up, so this will be 4 plus 3, it goes up to 7, and this will be minus 4 plus 3, it goes to minus 1, right? So the least value will be minus 1, and the greatest will be 7, right, for this graph after the transformations that affect the y-axis. Then for B, it says sketch the curve, this one. So for that, we are going to consider all the transformations. So first, let's start by drawing the original. So the graph, of course, let's put a 1 and minus 1. We have a point here. Just doing this to show you how you get to the other graph. This, then that. Like that, right? But now we know the least value for this curve that we're about to draw is minus 1, and the greatest is at 7, right? So this point that was originally at 1 will now be at minus 7, right? That's for y, going from minus 1 to 7. Then for the x values, it's cos 2x, and if we have 2x like that, we know that there was a stretch of factor 1 over 2 in the x direction. If it's 2x, the factor is half. If it's half x, the factor is 2. So there's a stretch of factor 1 over 2, right? So it's like us dividing all the x values by 2. So if we divide this by 2, we get this So we know that the point that was at half pi will now be at what? Will now be at a quarter pi. This point is now here, right? Then the point that was at 8 pi will be at half pi, so it's here now, right? Then this point that was at 3 over 2 pi, if we divide that by 2, we get 3 over 4 pi, which is here now, right? But since we're going from 0 to 2 pi, we have to continue this, right? So if we look at the pattern, the next point will be at 7, and the next one will be here, the next one will be here, here, and here, right? So let me just rub this one out. So joining these points, we get a graph that looks like this. Going from -1 to 7, right? And we name our graph. It's y equals 4 cos 2x, 4 cos 2x plus 3, like this, right? Then you get your 2 marks for that. Then part C says, hence determine the number of solutions of the equation 4 cos 2x plus 3 equals 2x minus 1. So if we look at this, you can see that that's our expression for the curve we just drawn. It's 4 cos 2x plus 3, right? So we want the solutions of that being equal to this, right? And this is a line, y equals 2x minus 1. So we want the points where y equals 2x minus 1 meet with y equals 4 cos 2x plus 3. So we know that at that point y is equals to y. That's why they wrote this equals to this, right? So for y equals 2x minus 1, it crosses the y-intercept. It crosses the y-axis at -1. So the y-intercept is -1. So it is a point here. Let me use a different color. It is a point there. Then it crosses the x-axis at, so the x-axis y is 0 equals 2x minus 1. Then 1 equals 2x. 1 over 2 is equals to x. Right, so it crosses the x-axis at half. So half is probably somewhere, let me see, a quarter pi, 1 over 4 pi, that's 0.78. So it's probably so it's here, our -1, and our half is probably somewhere here, right? So now drawing that line, we have something that looks like this, right? And now looking at this, it crosses the curve here, and here, right? So we have 1, 2, and 3 solutions for that. So for part C, we're saying hence determine the number of solutions for the equation 4 cos 2x plus 3, because that is 3 solutions. right? Then you get your mark.